Good afternoon, everyone. My name is Chris Dearden. I'm a solutions architect with Veeam Software. I'm going to talk about 8 ways you can protect your virtual machines offsite. The first thing is why we actually need to move data in the first place. I start with a little bit of a quote. And this guy, Tennessee, clearly did not work in data protection. Success and failure are equally disastrous. I think failure is a bit more disastrous if you are talking about backups. The average cost of downtime, for enterprise companies could be measured in hundreds of thousands of dollars per second. So, it is pretty important. But we need to look at the domains of failure. Now, you've got different protection policies. We learned in the last session with Craig about high availability, and particularly high availability at the application layer. And that's at the center of what I've decided to call the concentric circles of doom. A little bit like Dante's 7 layers of hell, but slightly upside down. So we start in the center, the smallest domain really big within an application. And you can protect an application by high availability in that particular app, multiple instances, sharding databases, so on and so forth. But if something a little bit bigger goes wrong, then you start to look at, well, what if an OS fails or a virtual machine fails? And then you're looking at the actual backup of that machine. Then you've got server clustering, pretty typical way of getting around that. You could run a 2-node cluster. If you lose an OS, fail it over, it's all good. What if something even bigger fails? So what if you actually start to lose an entire VMware cluster? You're starting to need to move that to a different location. And the worst one, the blue circle in this, what if you lose a site? Whether it's through a known disaster, so if you have a big power shutdown, or if you have got something that is a big catastrophe, the whole earth killer scenario. Site-wide failure is pretty much the worst thing that can happen to your day if you're working in IT. And it's learning about how you protect that. And the only really way to do it is to have copies of your data off-site. If it's on-site, whether it's in a fireproof safe, there are chances that you could lose some of that. So I'm going to go through these 8 different ways that you can move that data off-site. Some of them use some backup software you may or may not have heard of. Some of them don't. And this first one doesn't. Storage replication. Here's our typical stack. We've got some VMs sitting on some hosts, sitting on some storage. Our storage is replicated via the vendor's own method, whether that's over iSCSI or Fiber Channel, to a second site. And it has an offline or sort of read-only copy, depending on your vendor. And that's connected to some hosts and some VMs which are there, but they're powered off. You can't really access them because you can't really access the storage. And if something goes horribly wrong, you break that mirror, you make the storage available, read-write available, and finally power your VMs up. And that can work for a pretty good site availability thing. The problem is that you're then locked into a particular hardware vendor, which is great for that hardware vendor. And also, you've got a whole site that's sitting there that you can't really do much with. It's got data that's being replicated to it, but you can't write to that data. You've got virtual machines that are sitting there registered, but you can't power them on. So whilst it gives you the availability, you can't really drive any usage out of that. If you had a smaller amount of machines that you wanted to make available, not necessarily an entire data store, you could look at replication at the host level. Number of ways to do this. Not least to mention with the Veeam backup, but there's also the VMware host-based replication, where you're just moving individual virtual machine data between 2 hosts. So the hosts on your source and target side are powered on, the storage is read-write and available, but of course you now have double the amount of storage on site because a replicated virtual machine on site A takes up the same storage as it does on site B. Replication is not necessarily sort of the be-all and end-all, particularly for the data level. So actually, there's one of the smaller circles of doom, because data corruption on site A, well, that just gets replicated straight away to data corruption on site B. So whilst it can protect from a site-wide failure, it might not be protecting you against application-level failure. It wouldn't be VMworld without someone saying to the cloud at least once, and that's one thing you can do to your backups. You can take them to the cloud. Number of ways you can do this: create a backup file and use our cloud edition, or you could use a cloud gateway, which will then automatically write data up to the cloud. And that's great until you want to restore it. So any data you write to the cloud, you have to retrieve from the cloud in some way. Some vendors will charge you quite a lot for it. Because that storage that's sitting in the cloud, you can't really do any sort of restores in there because that cloud is just storage. There's no intelligence, there's no computer around it. Tape, still not dead. Alternate destination instead of the cloud. At least this time it's on a piece of physical magnetic media that you own. Again, take a Veeam backup, write it to tape. You can even do this with the free version of the tape software, which is sort of replacing what was NT backup for tape, and let Iron Mountain ship it off. Tape's great for long-term archiving. You know, it's very cheap. Its cost per gigabyte is pretty cheap. You have to factor that in with the time to restore it, though. If you have got that site-wide failure, you might have to retrieve a tape, stream it all off onto disk, and then restore it. So you know, plan for that when you're looking at your recovery time objectives for that site-wide failure. You could just copy your backup job files, and this is something that's been done probably to the version, well, up to version 7 of the backup solution. Create a backup, create a copy of the backup. Whether you do that via rsync, robocopy, you could do it via replicated storage, you could put it onto a USB disk and take it to another site. The problem is that if you're starting to do scripts, you're adding a bit of extra complexity. It doesn't necessarily scale as well. And that you might, well, you're having to copy quite a lot of data, often having to copy full backups, which means your storage requirements are going to go up a little bit for it. But we can take that copy of the backup job, and in version 7, we can turn that into the backup copy job. Backup copy job is like a regular backup, except instead of using the source virtual machines as a source for the backup, we actually use the backup file. This is great because it doesn't hit your virtual machines twice. So virtual machine, once it's been backed up, it doesn't have to get involved in the copy process. We use a couple of data movers to do this. We've got some WAN optimization that goes on between the two. So use multiple TCP streams, that sort of thing. And you can then have a longer return retention on cheap storage offsite. We can add in GFS restore points to that, so if you do need to retain a certain number of monthly or weekly backups for archival purposes or compliance reasons, you can do that on that sort of offsite storage. You can take that and combine that with the cloud that we spoke about earlier and add some brains to it. So instead of having our cloud storage that we had in the earlier step, we'll have a cloud provider that's not only giving us some storage, but giving us some compute as well. And that means we can start to do these copy jobs. We can be very efficient as to how much data we use with them. But also, we've got the ability to do restores into the cloud. You can leverage a cloud provider's own platform. They've already got the backups there. They've got something to restore them to. You can start to drive those restores. You can also make more use of them with a sort of file copies. When bandwidth is tight, it's not always possible to do a full copy, even of the incremental change block data. And to do that, we can do some WAN acceleration. It's a process that runs on top of our data mover, and we'll use a sliding window dedupe and a global cache to ensure that it's only really sending the data it has to send. In real world figures, I've seen sort of 20 times less data that you're having to send over a wire. And when that wire is very, very small, that might just be enough that you need to be able to get your implication off site in time. And you know, by failing to prepare, you're preparing to fail, as Ben Franklin said. But I'd like to prepare to fail over, that is, if you're replicating. Thank you very much.